All right, here's part two of a screencast for the SPSS analysis of personality uh, assignment. And so we've got just a few more questions, but each of them are a little more involved. First is, if you look again at the data, we've got this new personality factor called extroversion. And suppose we wanted to know whether gender impacted extroversion, whether men were more or less extroverted than women. And you can see there's different values of gender. There's actually more than two, but there's a few people who chose to prefer not to say, which got coded as prefer here. To test this, we will go to compare means and do a independent samples t-test. Now, because gender is a between subject variable, we do an independent samples t-test instead of a paired samples t-test, which we would do if we measured the same thing in two ways on each person. So the test variable, you include extroversion, and really any of the variables, other variables you want to put, you can do simultaneously. And then the grouping variable, you include gender, but you also have to define groups, and this is a little inconvenient, but you have to type out male and female here, which are the levels that you want to compare. And hit OK. This will bring up this t-test, and again, the first thing that this shows you is this test for equality, variances. Recall that the t-test requires your two groups to have the same variability in order for it to make the right inference, and if they don't have the same variability, those inferences won't work. So you can test that with this Levine's test, and the F value is 0.4, which is pretty small. The significance is 0.5, which is really big. So this is not, this test for equality of variances doesn't reject the null that the variances are equal, which means that as far as you can tell, the variances of these two groups are equal. Men and women have the same variability along this dimension. It doesn't mean they're the same, but it means they have the same amount of variability. Now, over here is where the t-test is, and there's two rows. One is if your variances are assumed equal, and one if they're not assumed equal. And because this was not reliable, these are going to be almost exactly the same. You can see they are. The t-value is negative 0.24, which is pretty small on 118 degrees of freedom or 114.5 degrees of freedom for this. In either case, it's not significant. 0.8, the value is 0.8, and we usually use a criteria of 0.05 or smaller to consider something significant. Then there's some other things about confidence intervals and standard errors. So this shows that for extroversion, there is no difference between men and women. There was also this difficulty variable that before taking this, they did one of three levels of a math test that were easy, moderate, or difficult. And because there's three levels here, we could do three individual t-tests, but that's a little inefficient because you have to do 1 to 2 and 2 to 3 and 1 to 3. Plus, you're losing some of your variability that you can understand. So because people, well, in this case, not really, but you're losing some of your ability to model the whole population in one model. So we're going to use a univariate, a one-way ANOVA to do this instead, this three-level. So we're going to go to compare means again and do a one-way ANOVA, and in factor difficulty, this is the independent variable. Extroversion is the dependent variable, even though in this case you might actually you might think of a personality factor as an independent variable. Here we're trying to ask whether the dependent variable. All right, sorry for that. There was a little mix-up. Anyway, so we have difficulty as a factor and extroversion as a dependent measure, because we want to see if you did something really difficult before you took the personality scale, did it impact your view of your own personality? But then I'm going to do hit post hoc tests, and I'm going to click the 2 key, which will give me sort of like t-tests for each of the pairs after you do this test. So I hit OK, and the results come here. This is the basic ANOVA table, and this uses an F-test. And an F-test, the larger the value of F, the bigger difference there is you can explain. And an F of 0.5 is relatively small and will probably never be significant. It has to be 2 or 3 or 50 in order to be significant, depending on the number of degrees of freedom in your between groups and within groups. So this F-test shows that there is no, that the difficulty of the test didn't impact their personality at all. And in order to report this, if you were reporting this, you would write something like F, and there's 2 degrees of freedom. It's 2, 118, 2, 118 is equal to 0.5. P is equal to 0.605. And you would say something like, a one-way ANOVA showed that the difficulty of the test did not impact the extroversion personality score, and then put this in parentheses. There's also these post hoc tests, which, especially if these were significant, you might want to wonder, well, is it easy is different than moderate? Is it moderate's different than difficult? So this gives all pairwise comparisons. And these are interpreted very similarly to a t-test, and you can see the significant values of these are 0.59, 0.96, and 0.75, which means there is no difference. This nowhere here did it actually show us what these values were. But there's another way of interpreting this, whether these groups are similar or not. I think if you do there might be an option here to include tables. Well, there's at least to include a means plot, which will tell us what the mean values of each one are. So here is the actual plot of the means, and in fact, in this case, it does go up, and this is not extremely small. It goes up over 1 unit, but the variability across people is so big that this is not a significant difference. So maybe if we had 1,000 subjects and this pattern still showed up, we would be able to see it. But then you still have to recognize that it is a relatively small phenomenon, that it's only 1 unit and we can only detect it with 1,000 people. So anyway, this was not significant, and that's what we would report, that this difference is not significant. Now, what if we wanted to test both gender and difficulty at the same time? Now we have 2 independent variables, and we can't do that with the t-test, we can't do it with a univariate ANOVA, but we can do it with a factorial ANOVA, and in SPSS it's under the general linear model univariate option. So general linear model, not generalized linear model, but general linear model univariate. And now I can put in as a dependent variable extroversion, and I can put gender and difficulty in as fixed factors. In some cases, your independent variable would be treated as a random factor, but in these cases, we'll just use a fixed factor. And I'll hit OK. And now we have a more complicated ANOVA table like we saw before, with F-tests related to each thing, but it's interpreted first as it gives you an intercept. The intercept is sort of the model if I didn't know anything. If I had to describe everybody by a single number without knowing anything about them, this is what the model would be. And this is usually significant, and whether or not it's significant typically doesn't matter. but all of the other models are compared to this intercept model. So here you're asking whether the gender effect matters. So it asks, does the gender effect matter with respect to all the other factors? And here's an f-test. The f-test is f value is small, the p-value is large, so gender didn't matter when you're accounting for these things together. Difficulty, here is the f-test for difficulty. Difficulty is relatively small, p-value is large, so it didn't matter. There's this gender by difficulty interaction, which means maybe women are affected by difficulty but men aren't, or vice versa. And again, this was not significant. The f value is a little larger, but it's still not significant. And so for each of these, you would report an f value of, say, for the intercept, f2, comma, and then the error, 114. 114 is equal to 0.277, p is equal to 0.758. Notice that the degrees of freedom is related to the number of levels, and so difficulty we had 3 levels, so degrees of freedom is 2. Gender, we actually had 3 levels. We had male, female, and prefer not to say. That's why this is a 2. And in this case, it might be reasonable to actually eliminate that prefer not to say, so we just have the comparison of the 2. It also, if you chose this option, will produce post hoc tests that will do the same Tukey tests that we did before for difficulty, easy versus moderate, moderate versus difficult, etc. And you see, again, none of these are reliably different. All right, well, that's it for this walkthrough of using SPSS.